There's an island smaller than Maryland. Inside a few factories there, one company decides something huge. Whether your phone works, whether your car starts, whether a fighter jet gets built, whether the newest AI model even exists. If that company stopped tomorrow, most of the modern economy would stall within weeks. The company is called TSMC, Taiwan Semiconductor Manufacturing Company. You've probably never said that name out loud. But TSMC now makes 72% of the world's contract manufactured chips. At the most advanced level, it makes 90%. It even makes 99% of the chips training today's biggest AI models. One company, one island. Almost the entire tech economy sits on top of it. So how did one company end up holding that much power? And what happens if it ever lets go? Apple relies on it. NVIDIA relies on it. So does nearly every AI company on Earth. None of them can build these chips themselves. Only one company can. And it started as a bet nobody else wanted to make. In 1987, an executive named Morris Chang started TSMC. He raised $220 million. Half came from Taiwan's government, half came from private investors. Back then, every major chip company designed its own chips and built its own factories. Intel did both. Texas Instruments did both. Motorola did both. Chang proposed something different. He wanted to build a factory that made chips designed by other companies and never competed with them. That's called the foundry model. This is a company that manufactures chips it did not design for customers it never competes against. At the time, it sounded like a losing bet. TSMC's first customers were Intel, Motorola, and Texas Instruments. They handed over their oldest, least profitable chip designs. Nobody wanted to waste real factory space on outdated products. TSMC took the leftovers. Nobody else wanted them. That single choice created an entirely new kind of company. Businesses that design chips but own no factories at all. NVIDIA is one. Qualcomm is one. Even Apple's chip division works this way now. The industry has a word for companies like that. Fabless. No factory. All design. TSMC makes the difference possible. That decision looked small at the time. It wasn't. It quietly rewired the entire electronics industry, and by the time anyone noticed, it was already too late to undo. Fast forward to 2025, the numbers are hard to believe. That quarter, TSMC hit 70.2% of the entire global foundry market. By the fourth quarter of 2025, it climbed to 72%. Its closest rival, Samsung, held just 6.5%. That quarter alone, TSMC brought in $30.24 billion in revenue. For comparison, that's more than the entire annual revenue of most Fortune 500 companies, earned in 3 months. In 2025, something else changed. NVIDIA passed Apple as TSMC's biggest customer. NVIDIA paid TSMC about $23.4 billion that year, 19% of all TSMC's revenue. Apple, TSMC's anchor customer for over a decade, came in second at 17%. AMD makes its processors there too. So does Qualcomm. Almost every major chip designer in the world, in some way, ends up ordering from the exact same handful of factories. Think about that. The chip inside your newest iPhone, the chip training the biggest AI model on Earth, both pass through the same handful of factories, built by the same company, on the same small island. TSMC looks unstoppable at this point, but even a company this dominant has a weakness, and it's not one most people have ever heard of. To make its most advanced chips, TSMC needs a machine called an EUV lithography system. It's a tool precise enough to etch patterns smaller than a strand of DNA onto silicon. There's exactly one company on Earth that builds these machines. Chip advancement is measured in nanometers, the size of the tiny circuits packed onto each chip. Smaller numbers mean more power, packed into less space. the smallest, most advanced chips today are measured at 2 and 3 nanometers. You've probably never heard the name ASML. Almost nobody outside the industry has. But without this one company, none of what you just heard even exists. That company is ASML, based in the Netherlands. ASML holds a total monopoly on EUV lithography. Not a dominant share, an actual monopoly. No other company on Earth, including in China, has matched the technology. Each machine costs more than $150 million. It ships in pieces, across 40 freight containers, on 20 trucks, on 3 cargo planes. A specialized team takes months just to install one. TSMC is ASML's biggest customer, but the dependency runs both ways. TSMC is the only company on Earth that can buy and run these machines at the scale ASML needs to survive. Neither company works without the other. So the phone in your pocket depends on one company in Taiwan. That company depends on one machine, built by one company in the Netherlands, with no second source anywhere. If this is such an obvious weak point, why hasn't anyone built a second one? Money isn't the problem. That's the part that surprises people. A single advanced fab, short for fabrication plant, the factory where chips get made, costs $15 to $20 billion. TSMC's newest 2 nanometer facility cost more than $45 billion on its own. Even under ideal conditions, building one takes 3 to 5 years. Equipment alone eats up 70 to 80% of that cost. At the smallest scale, a single dust particle can ruin an entire chip. These factories need cleaner air than most hospital operating rooms. And here's the part money can't fix. Building the same fab in the United States costs roughly twice as much. It takes roughly twice as long. Same equipment, different result. Why? Decades of specialized labor, supplier networks built over 50 years, institutional knowledge that lives in one place and nowhere else. You can't buy that. You can only grow it, slowly, over time. But that's not even where this gets strange. You don't need a war or a blockade or any dramatic event to see this system break. It already happened in 2020, without a single act of war. Between 2020 and 2023, a global chip shortage hit. Pandemic factory shutdowns triggered it. Automakers had canceled chip orders early on, expecting sales to drop. Then demand came roaring back, and there weren't enough chips left. In 2021 alone, the shortage was projected to cost the global auto industry $210 billion in lost revenue. Separate estimates put the hit to the U.S. economy at around $240 billion in that single year. Nearly 9.5 million vehicles were never built in 2021, simply because the chips didn't exist. Another 3 million were cut in 2022. Delivery times that normally ran 3 to 4 months stretched to 10 or 12. And that was just an accident, a side effect of a pandemic, not a decision by any government. Which raises the real question: what happens if the disruption isn't an accident next time? Taiwan sits about 100 miles from mainland China. China has never renounced the option of taking the island by force. For years, analysts have called TSMC's dominance Taiwan's Silicon Shield. Stop and think about that distance. 100 miles. That's closer than some people's daily commute. The theory is simple. Taiwan's chip factories are worth more to the world intact than any territorial prize is worth to China. So everyone has an incentive to keep the peace. But that shield isn't a law of physics. It's a bet. And several governments are already hedging against it. Economists estimate a Chinese blockade of Taiwan, just a blockade, not even an invasion, could cost the global economy $2.7 trillion. A full-scale war is estimated to cost more than $10 trillion. Since 2020, China has worked to cut its own reliance on Taiwanese chips, building up its domestic manufacturing instead. That shield is already thinner than it used to be. China doesn't even need an invasion to cause damage. Its Coast Guard could quarantine the island, inspecting every ship leaving its ports. The chips would still get made, they just couldn't leave. The United States pushed back too. In 2020, it began asking TSMC to build outside Taiwan for the first time in the company's history. TSMC committed $165 billion to new factories in Arizona. The U.S. government backed that with $6.6 billion in direct funding, plus $5 billion in loan guarantees, under a law called the CHIPS Act, legislation designed to bring chip manufacturing back onto American soil. The first Arizona factory started producing chips in 2024. So here's the honest answer to the question we opened with. The system holding up the modern tech economy is fragile, genuinely fragile, but it isn't undefended. Money, diplomacy, and new factories are already being built to hedge against the risk. The shield may be thinner than it once was. It hasn't broken yet. We covered business email compromise in another CoreWire video. That story ran on a hidden assumption that a message from someone you trust is safe to act on. This story runs on a different hidden assumption, that the most advanced technology on Earth can keep depending on one factory, on one island, powered by one irreplaceable machine from the Netherlands. Every AI breakthrough, every new phone, every advanced weapon system built by any major power on Earth quietly assumes this arrangement holds. CoreWire exists to look at systems exactly like this one, invisible, massive, and load-bearing. So next time your phone updates or a new AI model launches, remember where that starts. 100 miles from a border that has held since 1949. If that factory ever went dark for a year, how? Many industries do you think would still be standing at the end of it? Put your answer in the comments. There's another hidden system just like this one waiting in the video right next to this one. Same fragility, completely different shape.